Good afternoon, everyone. So let's jump straight into some of the technicals on ETFE. So, what is ETFE? First of all, ETFE is an acronym, ethylene tetrafluoroethylene. And I hope you've all had the chance to visit the Jewel at Changi. If you haven't, an amazing ETFE canopy. So ETFE is not a plastic, it's a fluoropolymer. And fluoropolymers are the good guys. They have longevity, they're not affected by UV, they're not affected by fire, low carbon footprint, sustainable. So ETFE has been around a long time, over 80 years, developed by DuPont. And it was our founders 42 years ago that brought ETFE into the construction industry. So what is ETFE system? The basic principle is 2 layers of ETFE welded together at the perimeter and secured into an aluminium frame. Now the ETFE is inflated with normal air, meaning the air gives it the strength, the form, very high thermal performance, and most of all, you can get complex shape with incredibly lightweight structures. So I just want to go through some of the details and it will help us with the projects I show you later. So this is an underside view of a typical ETFE roof. It just looks like giant panels of glazing. The only way you know it's ETFE is in the corner you might see a very small flexible inflation pipe. And from above the same. You have 2 or 3 layers of ETFE fixing into an aluminium perimeter frame, which is then secured to the steel. So here you just see the system in its entirety, and those small wires are just anti-bird wires for sensitive projects such as airports. Now, there's also a single layer ETFE where the air is replaced with cables for its structural support. Now, is ETFE strong? It's incredibly strong. It's lightweight, but it can bear 400 times its own weight. This is a video almost 25 years old, a young Kevin MacLeod and our boss during the opening of the Eden project. And they're demonstrating how strong ETFE is. If you did this with glazing, of course, it would crack and the car would fall through. But with ETFE, the load gets distributed and shared across the cushion. Now I want to start with some of the most famous projects you'll know, but I'm going to focus on Singapore projects after that. There's a lot of projects I hope you've either seen on your visit to Singapore or you're going to visit shortly. So one of the most famous projects is the Beijing Water Cube, constructed for the 2008 Summer Olympics. It's currently the largest ETFE cladded building in the world, about 100,000 square meters. And each cushion averages about 7 meters. So you imagine we're getting close to the size of this stage as a single panel. Now what most people don't know is the water cube is actually a double skin building. The roof and the facade is cladded in ETFE because Beijing doesn't rain very often, it's quite polluted, and ETFE is perfect for that environment as it has a non-porous surface which will self-clean under the action of rain. But also the interior ceilings are also ETFE because it's an incredibly corrosive environment in a swimming pool, and ETFE is inert to such chemicals. Now, this is the tallest, I don't know if you've seen this building in Astana, it's the tallest cable structure in the world, designed by Foster's, 150 meter long cables, and ETFE panels stretched across. Now, one of the reasons they use the ETFE is because it's flexible and it's able to withstand the movement of those cables. But also, Astana is the second coldest capital in the world. And ETFE is able to provide a standard temperature environment right through the winter and into the summer, to the point where they even have a beach inside. So probably the most famous project in Europe would be the Eden project. Before this, it was a clay pit for the last 160 years. And the architects put in 2 biodomes. The domes are approximately 100 meters wide by 200 meters long. What's very interesting about these biodomes is the size of the panels. You're getting up to 8 meters across, weighing only about 5 kilograms per square meter. If it was glazing, as we know, it's going to be 95, well, closer to 90 to 100. But with a lightweight, flexible cladding, you also critically get lightweight steel. And at the moment, steel has never been more expensive as a material to fabricate, to ship, to deliver, to paint. So ETFE is a good savior on many projects when their budgets are expanding. And critically, if you're an architect and you want a lightweight structure that's elegant and open and less busy, ETFE is going to be the route. Again, one of the most, I would say, self-feed projects before COVID hit. This is Hudson Yards. It's the largest private real estate project in US history. And on the right-hand side, you have the vessel, and we did the shed. And the party trick of the shed is it's a moving building envelope. It doubles the footprint of the building so they can do special events. But critically, it's the show. You know, it's really the developer is being able to really sell his development as something unique. Now we must move on to one of the key points of using ETFE. As I said, it is the most sustainable, lowest carbon footprint and recyclable of all transparent materials. So in Arctic, this building connected 8 existing private and public transportation systems. And with the help of ETFE, having a lightweight structure, smaller foundations, high thermal performance, natural lighting, etc., it's the first LEED Platinum transit station in the world. But what's interesting with ETFE is, obviously, you just look at the difference in the size of the panels. We're seeing almost 11-meter long cushions compared to 2-meter pieces of glass. But what ETFE also does is give you a daytime identity and a nighttime identity. So in the day, the silver prints are protecting you from thermal gain, but those same prints at night make the building basically turn into a beacon of light, and it turns into a whole different attraction. And one of our biggest jobs, and of course, is in Kuwait. It's one phase was 74,000 square meters. We've actually done 4 phases now. It's 117,000 square meters. And why do they like ETFE over glass? Well, the critical one is obviously the thermal performance, but also Kuwait gets hit with some of the worst sandstorms in the world. And when the sandstorms come, it doesn't build up on the ETFE. The non-porous surface, the sand just rolls off onto the extrusions. So they don't need to mobilize rope access men like the glazing to go and sweep everything. They've also, of course, the ETFE allows plant growth inside while giving a cooling environment. And the idea of the avenues is cities from around the world, put into this retail and commercial environment. So I'm going to talk sector by sector that we work in to give you ideas where you could use ETFE, but I'm going to focus a lot more on the Singapore projects, and I hope you get a chance to visit them. So this was a contender last year. It's the new Sabana Jurong campus, designed by Safdie Architects. And it's got 3 courtyards that are open to the public. It's well worth visiting if you can get down to the Sabanajahant campus. And the key thing here is, it is the first long-span cable-supported roof in Asia. So if you look, there's almost no structure. What it's actually designed is, it's a cable truss, just 20 mm diameter cables spanning almost 40 meters. But when you're working with Safdies, you get into the fine details, the fit, the finish, the shapes, how are you going to hide elements. So it's a real architectural piece of structural work. It's beautiful. We do a lot of facades, a lot more than people know. This is one in Singapore. It is a supercar vending machine. So you sit at the ground level, you say you want to see the Bentley on level 14, and the Bentley comes to you. And it's cladded in 15-story of ETFE cushions, top to bottom. That particular video. Now I'm showing the airport project here. I'm going to show you the Singapore ones, but for those who haven't had a chance to visit China over the last few years, this is of course the Zaha Hadid Dashing Airport, or well known as the Starfish. I believe it's still the largest single airport terminal building. I think some in the Middle East might challenge this now. It can handle 75 million passengers a year, and what they wanted when you dropped off was to actually be able to see the building and still be protected. So these are single layer ETFE canopies cantilevering out to protect you from the rain, but at least when you exit the taxi, you get a chance to see the actual building. Now, of course, I hope most of you would have arrived through Changi, and if you get a chance, go see the Jewel. It's a nature-themed retail design linking 3 of the Changi airport terminals. So we worked in 2 areas. One is the central oculus. It's essentially the world's largest indoor fountain, named the Vortex. And right at the heart there's a 12-meter wide giant ETFE cushion that allows this openness right through the middle of the fountain. And you would also be dropped off under our ETFE. Some of the really popular civic buildings we've done around the world. This is City Hall in Seoul. And it's 3 floating blimps right at the top of this building that wraps around the original civic center. It's a masterpiece. I think it's 6,000 individual cushions, every one a different shape. And at the very end, inside these blimps, you have cafeterias, you have libraries, entrances to offices, and right at the end, you have this amazing viewing platform over the city. Now, to compete with that, in Singapore, we have our Tampines Hub. It's the 2nd most visited public building in Singapore after Changi Airport, and it's really the heart of social integration and leisure events. And right through the middle of this, linking every single event, is our ETFE spine roof. Now, Clark Quay is not a new project. It was originally designed by Will Alsop, approaching over, must be over 20 years old. And due to global warming, climate change, and basically urbanization, the ETFE that was there wasn't good enough during the day. We were engaged by Capital Land. We did all of the studies. Everything was renewed with our highest performing cushions, over about 10,000 square meters. So right now, if you went down there in the day, you can sit outside, you can enjoy the environment, and it's very, very comfortable, naturally lit. They have ventilation systems. And again, at night, that ETFE becomes, a place to light up like a beacon and keep attracting people in. We even have these amazing drop-off canopies for the taxis. Now, I'm going to talk a little bit at the end on Sports Hub as a test case, as a case study. but this is, at the time, the world's largest PPP. And part of our works was the 20,000 square meter openable roof. That was also Singapore's largest flag. It's also one of the largest spanning domes in the world, 310 meters. And I'll get into more of this later, but it's been very well used lately. We had Taylor Swift here, we've had Coldplay was here. Everyone is under this canopy. And even outside, linking the indoor stadium and the outdoor stadium, you have this great big canopy. It's an amazing public venue, as well as used for the sponsorship events for those using the stadiums. Now, a big part of our business is retrofitting. Because we're so lightweight, this is Amsterdam's largest arena, or the country's largest stadium and arena. And what we did is, we were able to add a brand new facade on the building, 100% prefabricated steel and ETFE, no structural reinforcement needed to the existing building, and we turned a concave building into a convex facade, which is also a viewing platform over the city. So this lightweight material, 95% less weight than glass. How does it work in a typhoon? So this is one of our, sorry, let me go back. So this is a building we've just finished. It's called Pakal. It's right on Manila Bay, subjected to the full typhoon load. There's nothing to stop it. So part of our work, we don't just design, supply, and install ETFE, we do the lightweight structures. So this was the models we had made for the wind testing. And the reason we did that wind testing is this building in total covers about 900-meter length. And by changing the shape of the roof, making small changes, we could dramatically reduce the load on the roof, dramatically reduce the steel weight. In the end, we've got the lightest structures in the whole of the Philippines. We're approaching nearly 40-meter spans without trusses. And I think this summarizes what ETFE can do. You can enter the most extreme environments and have the lightest, most efficient, most elegant structures possible. So some of the images now, again, we talked about this daytime and nighttime identity, especially in retail. They've simply added a strip of LEDs going along the side of the steelwork, and the light literally bounces inside of those cushions and glows. And it draws you in from the street level, and even they have Christmas lightings going up. They've done some amazing things just with a strip of LED. And what happens during a typhoon? So this is the same building, recent typhoon, the 120 kilometer-hour wind speeds. You can see the ETFE looks solid, but on a structural level, the ETFE is moving and absorbing that energy. And if you add flying debris, it would just bounce off the roof. It's a really low maintenance solution to these extreme weather conditions. Now, we don't just do big buildings, we do small. This is really a piece of artwork. This is something we did 15 years ago now with Heatherwick and Hugh Dutton. It's literally called the Ink Splat, and I think you can guess why. And if we just look in a little more detail, it's a single ETFE cushion, and then we have contoured steel making this scalloped shape. And literally one giant piece made for this. As I said, when you work with Heatherwick, you have to really pull out everything they want, you must deliver. Now, coming back to Singapore, this is one of the newest integrated sort of shopping, accommodation, leisure. It's called One Holland Village. And right at the heart, where all the public meet this building, is again one of our ETFE canopies. And it's really there, obviously, to protect you from the rain and the shade. But now it's become an art installation. Beautiful piece of hanging art. One of the largest projects we've done here in Singapore, and I hope you'll get to visit, is at Resorts World, Sentosa. So there's 2 integrated resorts here in Singapore. Marina Bay Sands is one, Resorts World is the other. We've got about 25,000 square meters of canopies here. And the reason those canopies are there is to make sure people can move around, day or night, rain or shine. It's not just to protect them, but it also is a good return on investment. Because if people can move around all the time, they're always spending money. And that's what the resorts had worked out, including Universal Studios. If you went to the Singapore Universal Studios, of course, they've got the themed ETFE, we've got the sci-fi zone, we've got the Hollywood zone. But they've located these canopies over the locations where you spend money. So it's very simple. If it's too hot or it starts raining, you go onto these places, and that's where all of the retail is and where all the restaurants are. And I was saying earlier, again, that transformation of ETFE, simple flood lamps, completely changes the look that they're trying to present day and night. Again, we can add patterns into the ETFE, so you can take a very simple steel structure, but put the pattern in the ETFE rather than have a very expensive steel structure. And again, this is down in Singapore at China Point. Before the canopy was introduced, it links 2 MRT stations. The streets here weren't used. In Singapore, it's either too hot, it's either too wet, or it's both. So what happened was they put the canopy in, part of a government program to allow good linkage between transport centers. But what happened is we see people would run, they would be running through the sun under the canopies, and then they walk through. And you might be able to see that they've also got jet fans going along the columns, and those jet fans are there to mimic a natural breeze. So you get a breeze of about, I think, 5 to 7 kilometers per hour, and that gives, again, an additional feeling of cooling. Education is, again, schools, universities. Singapore's home to the largest preschool in the world. It's called the Early Learning Village, 1,200 spaces, and it's attached to part of the Australia International School. And of course, they're very sensitive to skin cancer, sunburning. So we were able to selectively filter out some of the UVA, UVB to ensure the children could always play outside and the parents weren't worried about sunburn and future repercussions. And the final little bit on projects, I want to go back here. Let that video start. This is a real video in the corner there. This is the Adelaide Entertainment Centre. And because of the lighting and the shape of the canopy, it's just an entrance canopy, it is now a landmark. And again, we're just showing that whole thing about ETFE and illumination. You literally get 2 different styles of building almost free of charge. So I want to get back into a little bit of that technical data. Remember I talked about the cushions are actually inflated. So how are they inflated? Is it going to cost a lot of money? Is it a lot of maintenance? Well, that whole roof you see in the left-hand side picture is inflated by that small box the size of a suitcase. 70% of the time it's off, and when it's on, I think it's about $1 a day in electricity. And it's a typical German black box, or white box, I should say. It's fault tolerant, it has 2 blowers, it inflates the ETFE to a set pressure, and then it switches off. And the air always escapes, so it monitors, and if some air leaks, it tops it back up. Very efficient system, pretty much leave it alone and we'll help you maintain it for the lifespan. ETFE itself is naturally transparent. Now, of course, that will work in Northern Hemisphere countries who are going to want to gain heat. Of course, anywhere in Southeast Asia, that would be a nightmare, so we have to print the ETFE to give it thermal performance. What's interesting with our prints is from a distance, they turn into a tint. So this is a picture of the same skylight view from above, you see our silver prints, but from below they disappear and you still have that connection with the sky and with clouds and the sun. And we can change the intensity, we can change the geometry of those prints. And what we end up with is a full database of all of the thermal performance. So a two-layer ETFE cushion's the same performance as double glazing. These are non-printed values. With print, U values are averaging about 1 to 1.6, but with 95% less weight and carbon footprint. So the thermal performance is as good as double to triple glazing. As I said, we can add patterns, we can add color. 35 years ago, we took one of our original roofs. We took samples of it, and it hadn't changed mechanically or chemically for 35 years. The ETFE had not aged. So as long as you're maintaining the inflation system, that roof is going to be with you the lifetime of the building. Now, acoustics is an interesting one. I think this is some of the worst acoustics you'll get. But if you imagine this space, if it had a glass roof, all hard surfaces, and all the acoustics, all the noise is going to reverberate at you. And humans do not like high reverberation. We like to feel like we're outside. So ETFE is what we call acoustically transparent. So what it does is it literally acts like an acoustic ceiling. The noise can pass through and it doesn't reverberate back at you. You feel like you're outside. The material, as I said, was developed by DuPont. It's basically it's a sister of Teflon. That's lovely self-cleaning material, but it's much, much stronger. So again, under the action of rain, your roof, your facade, whatever you're using will self-clean. Right at the start, I was mentioning ETFE. Okay, it looks like a plastic, but it's what we call a fluoropolymer. Its main ingredient comes from minerals and not from petrochemical. So what you can see in this picture is when there was a fire, the ETFE simply moved away from the fire, created a smoke vent, and self-extinguished. So if you Google or look up ETFE and fire, the last 42 years, the most behaved material in the world because it actually lets the smoke out. Now in Singapore, we have something called the Singapore Product Listing Scheme. It's to allow all architects and engineers simply to look on a database. If the material's there, you're allowed to use it. You don't have to ask for exemptions. So ETFE is all tested. It's all the latest EN testing about flame spread and certified, but we have projects all over the world. So we've got ASTMs, ULs, whichever country you're working in. As I said, it is the most sustainable, transparent material that's available. It's recognized by all of the boards you would be working with, and in Singapore, we've got many projects on the green schemes which are here. And this was an example of a lot of our clients do this. They looked at, if I did this skylight in glass, what would be my weight? If I did this skylight in ETFE. Now this is an extreme case, I have to say. But in this case, the review using ETFE, the total weight of the structure was 6 times lighter than glass. As I said, that's an extreme case. It's not normally that good, but it's the longer the span, the greater the advantage. So I'm just going to run through what we would do as Vector Foil Tech on a major project. And I thought I'd do the Sports Hub. As I said, it's the largest spanning dome in the world, and it's also probably one of the few stadiums in the world with a moving roof. So this image sort of gives you an idea of scale. So the actual dome itself is about 310 meters wide. The peak is about 80 meters high, and as I said, we could fit Sydney Opera House inside. So these were the consultants that we worked with, and we were engaged as the specialist contractor by Dragage, the main contractor, or Bouygues, as you might know them. So again, some of the images we were showing you of the end product. But let's start right at the beginning. So Arup's challenge was to design a 55,000 seat stadium bowl that optimized views, but used up the smallest footprint possible. So obviously when they looked at all the principles, the dome was the most efficient structural solution available. Now, a key principle is that you have a very rigid fixed roof at the bottom, and then a very flexible ETFE roof on top. That's how they got the lightest structure and great savings. Now, the biggest part of our review, we were brought on very early, was to study what shape should that moving roof be to efficiently drain the roof, have the aesthetics, but also allow this structure to move. So I'll just go back. What we actually ended up with were these 3 meter wide, 45 meter long ETFE cushions. There's the image you see on the left. That was the most structural efficiency and practicality for the roof. Now, things you're never going to think about when you're doing, because not many people ever get to do moving roofs, is when you start looking at loading, you don't just look at your traditional load. You have to think about what's the loading when the roof is a quarter open, a half open, what's happening when it's open and closing, because you can get dramatic changes in load. So again, from all of the testing, we end up with this very simple roof plan, and we know the worst case loadings. Now we've got to deal with some very interesting issues. So the first thing, the roof sits on 5 runway trusses. Every one of those trusses is a different span. So every truss will deflect differently to the one next to it as the roof is moving. So again, one of the major issues was the varying deflection. Then you have to look at skew. Now, it's hard to see the size of this, but between those trusses is 50 meters. So a 50-meter structure is going to start warping as it has to span laterally between these runway trusses. Then we've got what they call fluctuating deflection. So as that roof is opening and closing, you're getting different load cases. Of course, you've got to look at the dead weight of the structure. And we also had this wonderful pin in the middle of our roof to make it even lighter. So we've got countless deflections, movements, rotations, and twists. But the end result was we had these lightweight trusses on the roof moving along those giant runway trusses. So we had to look at all of those different movements, and the roof structure had to take those movements. So the long and short of it took about a year, an incredible amount of work, but we actually dislocated the roof, and the ETFE and the steel can actually move separately. So all of those different rotations, twists, and deflections doesn't tear the roof apart. Now, the other big problem with a roof, this was mandated, it has to be Singapore's largest flag, 20,000 square meters, is when you have stadium lighting, they have what they call wash. You have this amazing amount of light pushing back out of the stadium, so your colored roof can disappear. You don't see the color because you have so much white light coming from the stadium. So again, another big set of challenges. So how we overcome it, we made a giant mock-up of different colors, different prints, different lighting schemes. But what we had in the end was a white ETFE with this dark print on the top of it. And how we solved the lighting was by having these pixels. So you have these lights, which is a LED with a lens on top, which then creates a 1 meter wide pixel. So you have 20,000 of those. You have a 20,000 square meter pixelated roof, which can actually dance, and it can, it's got messages coming across it. And finally, rain. We've all seen the rain of late. Singapore has always had very heavy rain. Has always had to deal with very, very intense rainfall. Here we look at about 330 millimeters per hour. So we have to design for that much rain per hour. So again, the big part is, where is this rain going to go? So we have to model the roof, and we have to model the flows and work out where all of that rain actually ends up in all the different positions of the roof. And you actually end up with this, it is a giant gutter, but that is Singapore. The law is very clear. We take we had to make a very large structural element at the end of the roof, and it's all covered. And I'm going to leave it there. That is an introduction to ETFE. Thank you so much. If anyone has any questions, we literally have a booth right here. Come and grab us. We can answer any of your questions. If there's, but yes, thank you very much.